Hi, welcome back to CS170. We're going to pick up on chapter 7, doing hex. Before I get into that, let me just go through a couple of things here. So as mentioned before, I have this media gallery. We also have the modules that has the reading material for every week. And I'll be adding on to this grid at the bottom. You can see here, September 5th, I'll be putting the videos on here, links to the videos here shortly. They go to the YouTube videos, but if you look here, let's go into the media gallery here, which I also have the link to here. You can see media gallery. You can see I organize it by week 1, week 2. So I'm going to be adding on to this shortly. So for your reference, if you want to look at any of the videos, hopefully I'm naming them with something fairly accurate, so you can jump to a particular description if you want to get more about that topic. Okay, so let's go. So 16 is basically base 16. We're working with base 2 before, and you've worked with base 10 all this time up till now. And now we're looking at base 16. Okay, and all that is 0 through 9, and then you add A through F to it. So what does that mean? Well, so you look at all these zeros and ones, right? And it's a lot, right? Just like what I was saying before, in in zeros and ones, like you only have two digits, right, to represent something. So therefore, you need a lot more spaces to represent a lot of information, right? And so if you had, let's say, the decimal where you can represent 10 different characters in one space, you obviously get a lot more combinations in a smaller space. And then if I extend that to 16, obviously I get even more, right? So you remember, if I look at 4, before the last lecture, I was talking about how many combinations you get, based on each digit, right? So if I have 1 digit, I can get 2. If I have 2, I can get 4. And then if I get 3, I get 8. And then I have 4, I have 16, right? 2, 4, 8, 16. And that's how we get to hex, right? And so I can take each of these groups of 4 and then map them to the hex equivalent, right? So essentially it looks like this, right? So here's all your hex, 0 through F, and then here's all your binary equivalents. So if you ask me to convert from binary to hex, this is probably the easiest thing to do. The easiest thing to do is to group them by groups of 4 and then just map them out like so and select it, right? And so if you do this for the exam, you do this for the homework assignment, what you would do is basically you can, show that you have this, binary to hex mapping, and show how you're able to group each set of 4 and pick the right character for it, right? So if I took this one, 0, 0, 1, 0, and then I was able to get a 2 from it, let's say, okay? So that's how you would show your work. So remember, when you're doing your conversions for your homework or for your exam, you're supposed to show your work, right? And this is how you would show work if you're converting from a binary number to a hex number, let's say, okay? All right, so what are we talking about when we say digitizing text, right? Because when you're looking at the computer, what it stores at, like I said, is zeros and ones. So it's not going to store letters there. So what do we have to do? We have to somehow convert your alphabet and all the other characters that you typically see, convert that to something that we can store in the computer. Okay, and so that's what we mean by digitizing text. Okay, store this into something that the computer will understand. Ultimately, it will be zeros and ones, right? So that's where ASCII comes in, ASCII, right? And that's what it stands for. Okay, and so this is something as a standard. And what does that mean by standard? That means, like, if you send me something and you tell me what format it is, I know what that is, right? It doesn't really, it's not a standard if you decide to represent this text as one standard, or whatever way you feel like representing it, and I feel like representing it another way. We can't talk, right? So we need a language that's common, that all of us can speak to, right? One computer to another computer. And so that's why you have this whole standard thing here. And so this is how we store information and transmit information to other people, other computers, let's say, and that's how they can communicate better. Okay, so that's why this standard is set up. And so they set it up 8-bit symbols, right? And so 8 bits means you can get 256 symbols out of it, right? 2 to the 8th. All right. And so this grouping of 8, they call it a byte. All right. So 8 bits equals to a byte. All right. Try to remember that. And on this table, it kind of shows the OCT, which is a base 8. You don't have to worry about that. All you care in this class will be decimal, hex, and binary, of course. Okay. So basically all of this basically means this is a mapping, right? And what is it mapped to is one of these codes here. Okay. So these are like special characters here all at the beginning. So probably what you care about is like maybe starting around here or so, right? Exclamation mark, you know, all the typical characters you see on your keyboard. You have 0 and all the way to a 9 and all of the alpha. You have your lowercase, you have uppercase, all of these. And you look to the left and what does it map to? Right, so if I store this in decimal, it becomes a 70. If I store this as hex, it's 46, so on and so forth, right? And of course, you would convert to binary ultimately if you're going to store this on the computer, okay? But this is how we represent all of the different text, the characters into some sort of number format, in this case, decimal or hex, right? But, you know, by the end of this class, you should be able to convert this to binary if you need to. Okay. And so this is like just a small snippet, right? So here's like the @ sign, and then here's like A through Q, let's say. Okay. And so you have something like this, right? And you say hello, right? This is like what you and I would look at as text, right? So how does that convert to something, right? Well, let's take a look at the first character. This is H, right? So where's H on here? There's H over here. And you look at the hex, that's 48, right? You can see 48 over here, right? That's how come you got 48, right? And so we're converting from this into hex, right? Like so. And then ultimately, if you want to convert this to binary, you can convert this to binary, okay? And and you can get that from hex, right? Because you remember that mapping that we had back here, like this, right? Look at the 4, 0, 1, 0, 0. Okay, and here we go, 0, 1, 0, 0, which is this 4 right here. So you can see how this rather compressed view in hex, you can see how big it became in binary, right? And that's the reason why we have hex. Okay, but this is how you go from ASCII to ultimately machine language binary. Okay, and you can do all that just by mapping. What you see on here is the left-hand side mapping table. Okay, Unicode. All you really need to know about Unicode is that you know, it basically gives you more combinations than ASCII does, right? So it's an extension of ASCII, okay? And really ASCII, because it was kind of driven by Western languages, you know, only covered a certain amount of characters. But when you want to get into, you know, more, let's say, non-Western language, you have more characters to pick up. So Unicode basically extends this out and give you more combinations so you can have a mapping to, you know, other languages essentially, okay? So this kind of shows the same thing before where you had the hex to the binary conversion. And of course, the decimal is basically 0 through 15, which is 16 permutations, right? Because you start with 0. So that's all this chart is showing, right? And this is something you should keep handy. You should be able to write this out on your own. If I asked you to create a mapping between hex to binary or decimal, this is the first thing you can draw out, and then you can kind of use this to just map it out. You see a binary group like this, then you map it to this, right? And again, this is more for you to show your work. Ultimately, if you do this enough, you probably memorize all of this stuff, but you probably don't do it that many times. But anyway, show the mapping and then kind of show how you map from one to the other, and that should be good, okay? So decimal and binary, right? So one thing to remember with, and before I go more into the conversion, just know that this is something that we're going to cover a bit more. You can look at the videos and the text that we provide or the links that we provide in the modules, but you can also get help during your recitation. So your recitation, your TAs will be helping you to practice the process to do these conversions, right? So one thing you want to kind of know is, this is a very common thing here: 1, 2, 4, 8, 16, 32, 64, and 128, right? That's basically how you kind of progress using the binary setup, right? So you remember here, if I only had one digit, you could either be a 0 or a 1. So 0 is 0, obviously. A 1 is a 1, right? And then you go over to here, you put a 1 here. That basically is representing a 2. Right. And the same thing, if you put a 1 here, that equals to a 4, right? And so on and so forth, right? And so for each of the places that you have a 1, you basically would add them all together, right? And so you can see there's like 2 zeros here, right? The 0 for the 16 spot and the 18 spot, right? That's how come this became 0 here and this became 0 down here. Okay, but all the other spots that have a 1, you basically get the equivalent of what you had up here, right? So you have 1, 2, 4, and then you have 32, 64, and 128, right? And then all you do is you add them all together, okay? And that's how you would convert it into your decimal, okay? So if I add them all together, then you get 231, like so, okay? So that's the idea when you're doing this type of conversion. So hopefully that's the easy way to think about that, right? So all you do is look at the binary number and then look at all the slots. And if it helps you, you can put exactly this thing up top: 1, 2, 4, 8, 16, 32, 64, and 128. Most of the time, when we ask you this on a test or whatever, this is the most we're going to ask you for, right? 8 bits. We're not going to go too crazy with this, right? So we're going to have like this 8 bits or a byte, right? As I said before. And then you can go 1 through 128 here like this. And then you can say wherever there's a 1, just kind of take that number and then add them all together, right? And that's your way of doing a conversion, okay? All right, so hopefully people get that. Like I said, don't worry if you don't get it just this second. You'll have more practice in your recitation. There's resources in the modules, and there's a whole ton of resources like YouTube or whatever that kind of go through this conversion. This is like a very common thing, and you have plenty of resources to try to look it up and practice it, okay? And so you also have like, let's say, conversion like this, where we're going to base 16, okay? And so it's the same type of thing, right? You have the hex of 48, right? And then, wherever you have that number there, you multiply it. So in this case, anything to a 0, that's a 1, right? So that's 8 times 1, you get that 8 here, right? And then 16 to the 1 would be 16, right? And then that's 4 times 16. That's why you get 64. So hope you can see this is very similar to what we just did with the binary, right? This is base 2, 1 to 128, 1, 2, 4, 4, right? All the way through. This is for base 16, right? So this is your 0 and this is your 1, right? And then you come up with this number here, and then you add the two numbers together to get your decimal equivalent, okay? And then, on the binary side, I mean, there's a couple ways you can look at it, but one way might be to do what I was saying before, where you have your hex to binary mapping, and then you would put that down at the bottom, like so, and that's your binary, right? So you remember there'll be like 4 digits here for the 8, and then 4 digits here for the 4, if you want to do that type of mapping, okay? And remember, you know, this type of notation here, right? So you have like 2 to the 0, 2 to 1, 2, 2, 2 cubed, 2 to 4, 2 to 5th, 2 to the 6th, right? And you can get this here, right? You have the 64 and the 8, right? So you can see all the zeros here, so those don't count, okay? All the zeros here, right? And then you can see 1 here, right? 1 times 2 cubed, which is why you got this 8 here. And then you got 1 times 2 to the 6, which is why you got the 64 here, right? So that 64 plus 8, again, equals to 72, right? So that's how you got the binary up here, right? So from a binary perspective, you can see the 0 goes to the 0, 0, 0, 0, 0, 1, 1. Okay, so I hope that makes sense to you, right? The binary here matches up to all of the 1, 0, 0, 1, 0, 0, 0 over here. Okay, so that's how mechanically you would do this type of conversion. Okay. All right. So converting from decimal. Okay. So I guess they call this like the remainders process, or the doing this by remainders. Okay. So, oops, where am I? Yeah. So let's hit. You have the 72 here. So let's do 72 here. Okay. I'm gonna skip the hex part. Let's just do the binary part here. Okay. So here you can say, let's say the 72 number, right? You divide it by 2 because that's base 2, and you get 36 with the remainder of 0. Okay, then you take this 36 number and bring it down to here, and then 36 divided by 2 equals to 18. Again, you have a remainder of 0, right? And you keep on repeating this all the way down to the bottom, right? 1 divided by 2 equals to 0 with the remainder of 1. Okay, well, so how do we get to here? So I kind of almost look at this like sort of like a tree falling down. You fall to the right, right? So you can see this 1, 0, 0, 1, 0, 0, 0. You have all this fall to your right, and that's how you end up with 1, 0, 0, 1, 0, 0, 0. Okay. I'm going to pause here for a second, but you can maybe take a look at it and think about it and try to do this by hand and try some different numbers. Okay. And so this is our extra credit for this week. I have this little chart here, and if you can fill in the other parts here, actually don't do the base 8. You're not going to do this base 8 for the exam, so there's no point in doing it for practice either. So don't worry about base 8. So do base 10, base 2, and base 16, right? So on a piece of paper or on your Word doc or whatever you want to do this on, put in base 10, put in base 2, put in base 16, and then fill in all of these blank areas based on you doing that conversion. So in this case, you will be converting from base 16 to base 2 and base 10, right? So this will be part of your practice. Try to show work, right? Don't just put a number there, because if you did that on the exam, you're not going to get any credit for it. Okay, so if you show, let's say, the base 16, right, or hex, I might show you like that mapping chart. Remember, I showed you the mapping chart with the binary to hex, and say, oh, okay, so 8 maps to this and E maps to this, and that's how come I got this in base 2 over here. Okay, so try and do that. Of course, try to do it with this formal algorithm too, just so you kind of understand what the real mechanics is of doing it. And fill out this whole chart, and you can do that as part of your extra credit. You fill it in on a piece of paper, you can take a picture of it, try to show the work like I said, and send me email. And remember, when you do this for the exam, you have to show credit or you will not get any credit for, you have to show me the work, otherwise you will not get credit for it, okay? Like I said, your recitation, your TAs are gonna cover this in more detail. It is an important part of the class to be able to do these conversions. So please try to practice this process as much as you can. Take some notes and be prepared to do this, right? Last topic here is metadata, right? And as it says here, it's basically data about data, okay? And what does that really mean, right? So I'll give you an example. One example would be like if any of you take pictures, right? You take pictures with your camera, you take pictures with, let's say you have a digital camera, whatever, right? There's more to the data in that picture than just how to represent that picture, let's say. And so what might that be? Okay, you might imagine, well, we might want to talk about the camera that was used to take that picture. We might want to talk about the location where you took the picture at. You might want to talk about like, you know, the different settings that you used when you took the picture. You know, you might want to talk about other bits of information about, let's say, the person who took it, the date that you took the picture on, like whatever, right? They're not really directly related to representing the picture itself, but more useful information. So I can look at this later on down the line and say, oh, you know, they took this picture at 2 o'clock at night on so-and-so date at this particular location. And it gives me more useful information about the picture itself, okay? So that's what metadata is about, okay? And, you know, this is just kind of like a recap, right, of what we talked about for chapter 7. PNA, talked about binary, we talked about hex, we talked about doing conversions, right? Conversions between hex, decimal, and binary. We talked about what is ASCII, right? Extended ASCII, like what you can imagine, what is that, right? Here's ASCII. Extended ASCII is taking ASCII and go a little bit more, right? And then Unicode being really the more comprehensive or the more robust, you know, mapping to convert text or special characters or whatever into a format that the computer will understand. And then metadata we just talked about. Okay, you'll see more details on this when you look at the modules. So do look at the resources under modules. But other than that, that's it for chapter 7. I'll be cutting some more lectures later on, but hopefully what I recorded for today with chapter 7 is enough to get you going until I pick up with some more lectures later on this week. If you're in the middle of your vacation, enjoy the long weekend, and I'll talk to you soon. Thank you.